Good morning and once again welcome to my YouTube channel, PS1 and Excel International Math by Mr. Kamoto. And today I want us to practically get to reciprocal graphs by explaining example 3 of IGCSE page 132. And the question is talking about draw the graph of y is equals 10 over x plus x minus 5 for the range of x between 1 and 6. And that is just by first creating a table of values. And that is simply what we need to do. We need to have x and possibly including all the involved terms. After we identify x, let us have 10 over x. Let us have x again. Let us have minus 5 and let us have y. The reason why we should have each and every term here, like 10 over x here, plus x here, minus plus x here, and minus 5 here, is to be able to compute the value of y with ease, because we eventually know that the value of y is 10 over x plus x minus y. And in other words, the sum of the three rows will give us the value of y. And we are going to have the values of x here. So let's have x1, 2, 3, 4, 5, and 6. 10 over 1 is 10. 10 over 2 is 5. 10 over 3 is 3 and a third. 10 over 4 is 2 and a quarter. 2 and a half rather, not 2 and a quarter, 2 and a half. 10 over 5 is 2, and 10 over 6 is 1 and 2/3. You may write in decimal forms if you so wish. We repeat the same kind of value of x here, which is 1, 2, 3, 4, 5, and 6. The value of y is constant, minus 5 is constant, minus 5, minus 5, minus 5, minus 5, minus 5, minus 5. And now it's the time to compute the value of y. So the sum of the three rows, 10 plus 1, 11 minus 5, we have a 6. Then we have 5 plus 2, 7 minus 5, we have a 2. 3 and a third plus 3, 6 and a third minus 5 is 1 and a third. 1 and a third. 1 and a third can as well be written as 1.3. 2 and a half plus 4, that is 6 and a half minus 5, which is 1 and a half. 2 plus 5, 7 minus 2, minus 5 rather, we have a 2. And 1 and 2/3 plus a 6, that is 7 and 2/3 minus 5, 2 and 2/3, which can easily be, you may be interested to write this one 1.3, 1.5, 2.67, 2 points around 7 if you're using decimals. Fine, it is now time to get to the graph. The least value of x is going to be 1 and the highest value of x is going to be 6. So we can even use a ruler here so that we can construct a good graph. What is the highest value of y? 6. We have not seen one which is higher than 6. So we could even talk about let's bring the x-axis here, So we can have an interval 1, 2, 3, 4, 5, 6. Of course, when you're using a graph paper, it's well calibrated. 1, 2, 3, 4, 5, and 6. 1, 2, we should have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. When x is 1, when x is 1, according to the table, y is 6. When x is 1, y is 6. We are there. When x is 2, y is 2. Here we are. When x is 3, y is 1 and a third. 1 and a third, somewhere there. When x is 4, 1.5 or 1.5. 1.5, somewhere there. When x is 5, y is 2. We get back to 2. When x is 6, y is 2.7 or 2 and 2/3, around there. So our graph, using freehand, it should be something to do with, you can even start from this side. That is our graph. And of course, you name the graph immediately. Y is equals to 10 over x plus x minus 5. And as such, now we can go to answer the questions. This is the x-axis. This is the y-axis. Always name the axis. That is part A of the question. Part B says, use your graph to estimate the smallest value of y and the value of x where this occurs. The smallest value of y, the smallest value of y is the smallest value of y is around the smallest value of y is around this value. So you draw a tangent. The thing is that this question, to answer this question, you must be able to draw a straight line that connects with the smallest value of y, and it should be very accurate. Should be very accurate. Something to do with this. That's the smallest value of y. And as you can see, the smallest value of y is this one. You should be able to draw a tangent to the graph that touches the graph only once. To establish the smallest value of y, you can even produce that line if you want, but it should touch the bottom of the graph to show the smallest value of y, which to me is around 1.3. Y, this is part B, is equals to, or is around 1.3. And the value of x that suggests the value of x that suggests that value of y, it could be just this. This is the value of x, and you can see, and x is around 3.1, 3.2, 3.3, 3.2. You can see the value of the smallest value of y is around 1.3, and the x value corresponding is 3.2, so to speak. That is part C. That is part B. Part C, we are asked to say, state the values of x for which y is 2.5. State the value of x for which y, the values. State the values, because the question is state the values of x. The question is state the values. It's plural. The values of x for which y is equals 2.5. Again, what we should do, we should just come with a very good ruler and draw that line when y is equals to 2 and produce that line when y is equals 2.5, and the moment you reach there, you will find that that is when y is equals to 2.5, that line. You should just be able now to drop with it to get the corresponding value of x there, and the corresponding value of x here. So you can say y is equals 2.5 when x is equals to 1 point, let's say 6, and x is also equals to 5 point, let's say 8. So y is equals to 2.5 along that line. Along that line, you can see this is exactly 2.5. You produce it further along that line, and the corresponding values of x are shown in the graph. So be on the lookout, and of course make sure you can interpret these graphs accurately. Otherwise, that is the end of this topic, cubic functions or cubic graphs. You should be able now to sketch graphs, draw graphs accurately, and answer questions that follow. Fine, that's the end of this topic. Go to my YouTube channel, subscribe and share widely, and let us reason together.